Good morning, students. Today we shall see the next topic of our chapter, stereoisomerism. In the previous lecture, we have discussed about the definition of configuration. We have seen that configuration is the fixed or rigid arrangement of atoms or groups in space. We can assign the configuration by different ways. There are two methods of nomenclature. First one is relative nomenclature or relative configuration. Capital D and capital L is used to show the relative configuration, which is not included in our syllabus. Second method of configuration is absolute configuration, where R and S nomenclature system is used. R means rectus, S means sinister, right-handed, left-handed, clockwise, anti-clockwise. So this may be the meaning of R and S configuration. In that, we seen that the atoms or groups attached to the chiral center are assigned some priority. The priority is decided on the basis of their atomic number. We seen the sequence rules or the CIP rules given by Kahn, Ingold and Prelog. And by using those rules, we can assign the priority sequence to the groups or atoms attached to the chiral center. And then we can view the molecule from opposite side of least priority group. And then we can observe the sequence of 1, 2 and 3 priority groups. If the sequence is clockwise, then it will be R configuration. If the sequence is anti-clockwise, then it will be S configuration. Now, we shall extend our discussion of the same topic, assigning the RS configuration, but now by exchange method. First method was the direct method, where we observed the molecule from opposite side of least priority group. Now, we shall use the exchange method. In the exchange method, we shall start from assigning the priority sequence to the atoms or groups. The priority sequence will be assigned in the same way as we have discussed before, depending on the atomic number of directly attached atoms or groups. If the directly attached atoms or groups are same, then we shall check the next atoms. If isotopes are there, then higher priority will be given to the isotope having more atomic weight. In the exchange method, two exchanges are done. In the first exchange, lowest priority group is taken at the bottom. We shall just read the rules and then we will discuss the examples. Okay, so what is our first step? To take the lowest priority group at the bottom. If the lowest priority group is already at the bottom, then we shall exchange the horizontal groups. म्हणजे आपल्याला एक्सचेंज करायचाच आहे. लोएस्ट प्रायोरिटी ग्रुप जर बॉटमला असेल तर आपल्याला हॉरिझॉन्टल जे ग्रुप्स असतील त्यांना एक्सचेंज करायचे, आणि जर तो बॉटमला नसेल तर आपल्याला त्याला बॉटमला आणायचं आहे आणि बॉटमचा ग्रुप त्याच्या जागी जाईल. ओके, एक्सचेंज आपण म्हणतोय इथे. Then second exchange is done. In the second exchange, second priority group is taken at the top. And if second priority group is already at the top, then again we shall exchange the horizontal groups. So these two types of exchanges are done, and after doing these exchanges, the sequence is checked 1, 2, 3, 4. If the sequence is clockwise, then it will be R configuration, and if sequence is anti-clockwise, then it will be the S configuration. Now let us see these rules with the help of some example. From example it will be more clear. See here, bromochlorofluoromethane. This molecule is shown here. So we shall directly discuss it on the board. Instead of observing the PowerPoint slide, we shall make this example on the board. Remember the name, bromochlorofluoromethane. I hope you can read whatever is written on the board. Okay. So what was the name of that molecule? Bromochlorofluoromethane. Means to the chiral center all these different atoms are attached. As per our example, bromine is taken here, chlorine is taken here, here is fluorine, and here is hydrogen. So you first observe these atoms that are attached. Now assign the priority. In the previous lecture we have seen the rules for assigning priority. So which group will be the higher priority group? First priority? Yes, of course, bromine. Bromine is having higher atomic number, so it will get first priority. Then after bromine, what is atomic number of fluorine? It is 9. Atomic number of chlorine 17. Atomic number of hydrogen 1. So chlorine will get the second number. Second priority goes to chlorine. Third priority will go to fluorine because its atomic number is 9. So it will have third priority. Bromine is highest priority. Atomic number 35. Atomic number 17. Atomic number 9. And the least priority group is hydrogen. Atomic number 1. Now, as per our rules, in the first exchange, we shall take the least priority group at the bottom. See here, least priority group is hydrogen. So take this hydrogen in the bottom, means at the place of chlorine. So what will happen with this chlorine? It will take the position of hydrogen. Okay. So exchange both of these. Take the least priority group at the bottom. We can write here first exchange. Okay. In the examination also you will have to write this word, first exchange. RS मध्ये हे अशी फुली काढूनच घ्यायची. See one thing, in RS configuration in the exchange method we use the Fisher projection formula. Okay, याच्यामध्ये फिशर प्रोजेक्शन फॉर्म्युला मध्ये सगळे एक्झाम्पल आपले असतील. So after first exchange, bromine has not changed its position. It is at its original place. Fluorine is at original place. Hydrogen is now at bottom and chlorine has acquired the position of hydrogen. We can once again show the priority numbers. It is compulsory to show these numbers every time, because to show the exchange we must indicate the least priority and the second priority group, and finally at last we will have to observe the sequence of these priority groups. So at every step we will have to give these numbers. Priority numbers must be given. Okay. Now what is our second step? What we do in the second exchange? Second, okay, it is not necessary to write in words. You can show it like this. Second, you can show like this also. You can show in this way also. You can use Roman second. Okay, no problem. But this one will be good. Second. Here also you can write like this, first. Okay. So whatever is comfortable to you, you can use the notation. Second exchange. What we are going to do in the second exchange? We are going to take the second priority group at the top. And where this bromine will go? Of course, it will take the position of second priority group. In examination also, it is desirable that you show these arrows for exchange. So after second exchange, the arrangement will be like this. Again, directly draw this cross, okay, plus sign for Fisher projection. Now see, bromine is now not here. It has taken the position of chlorine. So bromine will be here. Chlorine has acquired the position of bromine. So we shall show this chlorine at the top. Fluorine unchanged, hydrogen unchanged. So this will be the arrangement after second exchange. Again, show the numbers because they are very necessary. 1, 2, 3 and 4. Okay. Now see, now observe the sequence of the priority groups. See, start from 1, 1, 2, 3, 4. The sequence is anti-clockwise and therefore we can show the anti-clockwise sequence like this. This arrow is not necessary finally. Okay. As the sequence is anti-clockwise, counterclockwise, left-handed, the configuration is S. S configuration. In final examination, if the question comes for 4 marks, then 2 marks will be for exchanges and 2 marks will be for configuration. If you just write that S configuration without showing any type of exchange, then you will get only 2 marks. Look at the example very carefully. Then we shall see the next example. Instead of writing the name, we shall directly write the formula. CHO, Cl, hydrogen and methane, methyl group. These groups are there. Okay. Give the priority. See, this is the chiral center. Directly attached atom here is carbon. This is CHO group. Can you see this CHO group? Perhaps not. I will draw this group with increased font size. CHO. CHO means what? C double bond O H. It is aldehyde functional group. Okay. C double bond O H. We have shown it CHO. It is simple way to show. So directly attached atom here is carbon. On this side, directly attached atom is chlorine. Here again carbon is directly attached, and here hydrogen is directly attached. So which group will get first priority? Obviously this chlorine will get first priority because it is having highest atomic number among these. आपल्याला यांच्यातल्या यांच्यातच कंपेअर करायचंय. तर इथे 2 कार्बन, 1 हायड्रोजन आणि 1 क्लोरीन अटॅच झालाय. So chlorine is having highest atomic number. So it will get first priority, first number. Which will be at second number? हायड्रोजन असणारच नाही कारण तो atomic number त्याचा सगळ्यात कमी आहे. त्यामुळे 2 नंबर एक तर CHO ला मिळेल किंवा CH3 ला. पण या दोघांमध्ये डायरेक्टली अटॅच्ड ॲटम जो आहे तो कार्बनच आहे. इट इज कॉमन. ओके. मग कोणाला द्यायचा आपण सेकंड नंबर? सेकंड नंबर देण्यासाठी सारखे ग्रुप असल्यामुळे आपल्याला पुढचा ॲटम जो आहे तो बघावा लागेल. इन CHO नेक्स्ट ॲटम इज डबल बॉन्ड O and H मीन्स 2 times ऑक्सिजन. हा पण आपण रूल बघितला याच्या अगोदर. 2 वेळा तो ग्रुप आपण घेत असतो जेव्हा डबल आणि ट्रिपल बॉन्ड असतील त्यावेळेस. डबल बॉन्ड असेल तर 2 वेळा, ट्रिपल बॉन्ड असेल तर 3 वेळा. सो हियर कार्बन डबल बॉन्ड ऑक्सिजन. So we shall treat that carbon is having 2 oxygen atoms and 1 hydrogen. In case of methyl group, all the 3 atoms are hydrogen. So this CHO will get second priority. CH3 will get third priority and hydrogen will get fourth priority. As per our rule, we shall do first exchange. First exchange. What is done in first exchange? Least priority group is taken at bottom. Least priority group is hydrogen, so it will be taken at the bottom. And this methyl will take the position of hydrogen. So this exchange will take place initially. So after first exchange, CHO will not change its position, it will remain. Chlorine will not change the position. But now this methyl has taken the position of hydrogen and hydrogen has taken the position of methyl group. Hydrogen is now at the bottom, least priority group. So first priority is here, second is here, third, and here is the fourth priority group. Now let us do the second exchange. Second exchange. What is done in the second exchange? We take the second priority group at the top. But see here, second priority group is already at the top. So in this situation, what we do? If the second priority group is already at the top, then we exchange the horizontal groups. So methyl will be transferred on this side and chlorine will be transferred on that side. Such kind of exchange will be now done at that place. So after second exchange, the situation will be like this. CHO is at its own position. Methyl is now transferred on this side, CH3. Chlorine on this side and hydrogen is at the bottom. Give the numbers. Chlorine first, CHO second, methyl third, and hydrogen fourth. And observe the sequence. What is the sequence? 1, 2, 3, 4. Again, it is anti-clockwise, and that's why the configuration is S configuration. The configuration is S configuration. Look at both the examples very carefully. Try to understand the difference. Take into account this situation when the group to be exchanged is already at its position, then we do the exchange of horizontal groups. Okay, next example we can discuss now. I will erase this one, this example. याला मुद्दाम मी पॉवर पॉइंट वरती जास्त दाखवत नाहीये, कारण पॉवर पॉइंट वरती नुसतं तुम्ही असं बघाल त्याला काही अर्थ नाही. हे प्रॅक्टिकली हे एक्झाम्पल आपल्याला कसे सोडवायचे ते कळालं पाहिजे. ओके, याचं स्लाइड दाखवणं जास्त सोपं जाईल मला, बट इट विल नॉट बी गुड फॉर यू. आणि मी नोटबुक घेऊन बसायचं सांगितलेलं आहेच. नोटबुक तुमच्याकडे असतील आता असं मी गृहीत धरलेलं आहे. आणि हे सगळे एक्झाम्पल तुम्ही सायमल्टेनियसली सोडवत चला तुमच्या नोटबुक मध्ये, सो दॅट यू विल हॅव प्रॅक्टिस टू ड्रॉ द स्ट्रक्चर्स एव्हरी टाइम. ओके, इफ यू डायरेक्टली ड्रॉ द स्ट्रक्चर इन द एक्झामिनेशन, then there are chances of many mistakes. So it is recommended that you must do the practice at the time of lecture and also after the lecture. Okay. Next example. Here is methyl group. Here methoxy OCH3. OCH3 म्हणजे मिथॉक्सी. इथे ऑक्सिजन आहे ना, मिथिल सोबत ऑक्सिजन म्हणून मिथॉक्सी. C2H5 इथिल ग्रुप आहे इथे आणि इथे हायड्रोजन. Solve this example. Start from assigning the priority sequence. See, directly attached atoms are carbon, oxygen, carbon, hydrogen. So oxygen is having highest atomic number. Give first number to this OCH3 group. Then second number will be assigned to methyl or ethyl? Yes, ethyl. Ethyl group will take second number because directly attached atoms are same, carbons. Next atom here is carbon and two hydrogens. Here all the three are hydrogens. So ethyl group will take second priority. Methyl will get third priority and hydrogen will get fourth priority. Now do the exchange. First exchange. फर्स्ट एक्सचेंज लिहून असा क्रॉस करूनच घ्यायचा, कारण तो करावाच लागणार आहे. सी, इन द फर्स्ट एक्सचेंज वी टेक द सेकंड प्रायोरिटी ग्रुप ऍट द बॉटम. Sorry, in the first exchange we take fourth priority group at the bottom. So take this hydrogen at the place of ethyl and take this ethyl at the place of hydrogen. After first exchange, methyl will be at its own place, OCH3 at its own place. Ethyl is now at this position, C2H5, and hydrogen is at bottom. Give the numbers. OCH3 first number, ethyl second, methyl third, and hydrogen fourth. Then do the second exchange. तिकडे जागा नाही आहे, त्याच्यामुळे आता इकडे खाली याला पुसून घेतो. इथे दाखवतो सेकंड एक्सचेंज. Second exchange. In the second exchange, we shall take the second priority group at the top. So exchange will be done between these two groups. Again, draw the cross. C2H5 is now at the top. C2H5. Methyl is here. OCH3, no change in the position. Hydrogen, it is at the bottom. Now, observe the sequence. The sequence is 1, 2, 3, 4. It is anti-clockwise. The sequence is anti-clockwise. And therefore, configuration is S configuration. Configuration is S configuration. So in this way, we can assign configuration to the chiral center. Now, take some examples for practice. I will show it on the slide, the examples for practice. See, these are the examples for practice. Write down all these 5 examples and solve them at your own. If you find any difficulty, then you can ask me in the comment box or directly on telephone. Okay. Now, let us see the next concept. The name of the concept is diastereomers. So, what are diastereomers? Before this, we have seen enantiomers. What is the definition of enantiomers? Enantiomers are non-superimposable mirror images of each other. Diastereomers are the isomers which are not mirror images of each other. बरेचदा असं होतं की आयसोमरची पेअर आहे, ठीक आहे, मग ते नॉन सुपरइम्पोजेबल मिरर इमेजेस जर असतील ते एकमेकाचे मिरर इमेज असतील तर आपण त्यांना म्हणू इनॅन्शिओमर, ठीक आहे. पण बरेचदा आयसोमर असेही असतात की जे मिरर इमेज असत नाही. मग जे एकमेकाची मिरर इमेज नाही आहेत अशा आयसोमरला डायस्टेरिओमर्स असं म्हटलं जातं. डायस्टेरिओमर लक्षात ठेवण्यासाठी सगळ्यात सोपं एक्झाम्पल म्हणजे सिस आणि ट्रान्स. सिस ट्रान्स आपल्या लगेच लक्षात येतं. सिस टू ब्युटीन अँड ट्रान्स टू ब्युटीन. लुक ॲट द एक्झाम्पल केअरफुली. सिस टू ब्युटीन अँड ट्रान्स टू ब्युटीन. बोथ ऑफ दीज आर आयसोमर्स ऑफ टू ब्युटीन. टू ब्युटीन ह्या मॉलिक्युलचेच हे दोघं आयसोमर आहेत, एक सिस आणि दुसरा ट्रान्स, ठीक आहे. बट दे आर नॉट मिरर इमेजेस ऑफ इच अदर. इनॅन्शिओमर मध्ये आपण जे बघितलं होतं, सपोज लॅक्टिक ऍसिड, ठीक आहे. लॅक्टिक ऍसिड मध्ये 2 आयसोमर आपण बघायचो, एक डी लॅक्टिक ऍसिड आणि एल लॅक्टिक ऍसिड. आणि डी आणि एल हे दोघं आयसोमर कसे होते? दे वेअर द मिरर इमेजेस ऑफ इच अदर. बट हियर इन केस ऑफ सिस ट्रान्स आयसोमर्स they are not mirror images of each other and therefore they are called as diastereomers. One more example is there. Sugars पण बऱ्याचशा ज्या असतात त्या सुद्धा डायस्टेरिओमेरिक फॉर्म मध्ये असतात. त्यांच्यात काय असतं की एखाद्याच कायरल सेंटर मध्ये बदल असतो, बाकीचे कायरल सेंटर सारखे असतात. एका ठिकाणी बदल असल्यामुळे मिरर इमेज ते होत नाही. The example given here is D-glucose and D-ultrose. See, the change is only at Where is the change? It is at second and third position. H and OH, they are having opposite arrangements in both of these isomers. And because of this change, these isomers are not mirror images, and that's why they are called as diastereomers of each other. One more thing is there. One more example we can see. A next type of isomer we can see. It is meso compound. What are meso compounds? So meso compounds are the isomers which contain more than one chiral carbon. याच्या अगोदर आपण कायरल सेंटर, कायरॅलिटी, कायरल कार्बन या कॉन्सेप्ट बघितल्या आहेत. आपण असं बघितलं होतं की कायरल सेंटर त्याच्यामध्ये असेल तर तो मॉलिक्यूल असिमेट्रिक असतो आणि ऑप्टिकली ऍक्टिव्ह असतो. पण काही कंपाऊंड मध्ये जे मोठे मॉलिक्युल्स असतात त्यांच्यामध्ये एकापेक्षा जास्त कायरल सेंटर असण्याची शक्यता असते. देयर आर चान्सेस ऑफ हॅव्हिंग मोर दॅन वन कायरल कार्बन. ओके, मोर दॅन वन कायरल कार्बन. बट though they are having the chiral carbon, they are optically inactive due to the symmetry. पण एकापेक्षा जास्त कायरल कार्बन असून सुद्धा तो ओव्हरऑल मॉलिक्यूल सिमेट्रिक जर असेल तर तो ऑप्टिकली इनॅक्टिव्ह असतो. आणि अशा मॉलिक्युल्सला की ज्याच्यामध्ये कायरल कार्बन आहे पण तरी सुद्धा सिमेट्री असल्यामुळे तो ऑप्टिकली इनॅक्टिव्ह असतो, such molecules are called as meso compounds. Such compounds are called as meso compounds. The famous example of meso compound is tartaric acid. You look at the structure of tartaric acid. It is having three isomers. One is D-tartaric acid. Second one is L-tartaric acid, and third isomer is meso-tartaric acid. Look at this meso-tartaric acid very carefully. I shall draw all these structures on the board to explain somewhat. Detail explanation can be given on the board. I shall draw the skeleton at first. Skeleton of all the three isomers. I have the duster to use. I will zoom the board so that you can see what I am doing on the board. See, I have just drawn the skeleton of tartaric acid. In the tartaric acid, there are two carboxyl groups. Tartaric acid is dicarboxylic acid. It is having two COOH groups. One is at the top, another is at the bottom. Then, apart from this, there are H and OH, which are having such arrangement in the D isomer. This is D tartaric acid. D-tartaric acid. COH at the top and bottom, HOH, OH. This is the arrangement in D-tartaric acid. Now see the L-tartaric acid. In the L-tartaric acid, COH groups are as it is, no change in the position of COH, but this HOH will get opposite positions. Here will be OH, H. याच्यामध्ये HOH असं होतं, इकडे OHH असं झालं. सेकंड ह्या कार्बन मध्ये डी मध्ये OHH होता, इकडे HOH झाला. Now see, both of these are mirror images of each other. आपण जर आरसा ठेवला इथे समोर, याला आरशात पाहिलं तर हा दिसेल, याला आरशात बघितलं तर डी टार्टारिक ऍसिड आपल्याला दिसेल. सो दीज आर परफेक्टली मिरर इमेजेस ऑफ इच अदर, डी अँड एल आयसोमर. दीज आर ऑप्टिकली ऍक्टिव्ह आणि यांच्यामध्ये पहा कायरल सेंटर आहेत. सी, दिस कार्बन इज कायरल सेंटर, दिस कार्बन इज कायरल, H, COH, OH आणि इकडे हा मोठा ग्रुप, म्हणजे चौघ ग्रुप वेगळे झाले. ऑल द 4 सबस्टिट्युएंट्स आर डिफरंट. सो दिस कार्बन इज कायरल कार्बन. Such asterisk is used to show chiral carbon. असा थोडा स्टार वगैरे केला जातो कायरल दाखवण्यासाठी. Now look at this carbon. Again this carbon is having 4 different groups, H, OH, COH and is big. So this carbon is also chiral carbon. So 2 chiral centers are there in this tartaric acid. आता याची सिमेट्री बघा, सिमेट्रिक दिसतोय का हा? नाही. इथून जर आपण प्लेन ऑफ सिमेट्री टाकलं तर इकडे H इकडे OH येतो, मीन्स इट इज नॉट सिमेट्रिक. आपण जर असं एखादं प्लेन टाकलं आडवं तरी सुद्धा काय होतंय, इथे OH आणि इथे H दिसतोय. सो इट इज नॉट सेम and therefore it is asymmetric molecule. Look at this L-tartaric acid. L-tartaric acid is also having 2 chiral centers. तसंच आहे सेम. या इथे ह्या कार्बनला 4 वेगळे ग्रुप, ह्या कार्बनलाही 4 वेगळे ग्रुप, म्हणजे हा सुद्धा कायरल सेंटर. 2 कायरल सेंटर आहेत, बट इट इज asymmetric. असं प्लेन टाका, यू विल नॉट गेट मिरर इमेज हाल्व्स. असं प्लेन आता सुद्धा आपल्याला मिरर इमेज हाल्व्स मिळत नाहीये, काहीतरी फरक त्यांच्यामध्ये राहतोच आहे. ओके, बट नाउ लुक ऍट द लास्ट वन, मेसो टार्टारिक ऍसिड. I will write the name at first and then put the groups. Tartaric acid, meso tartaric acid, meso, MESO. See, in the meso tartaric acid, carboxyl groups will have their same position. कार्बोक्सिल मध्ये काहीच बदल नाहीये, पण HOH मध्ये पहा, ह्या दोघांमध्ये काय झालं, एकाचा H इकडे असायचा तर दुसऱ्याचा OH असायचा. But in the meso tartaric acid, both of these hydrogens are on the same side. Both of the OH hydroxy groups are on the same side. हे सारखे सारखे एका बाजूला आले, त्याच्यामुळे काय झालं, the molecule became symmetric. हे ग्रुप एका बाजूला सारख्या बाजूला आल्यामुळे मॉलिक्यूल सिमेट्रिक झाला. आता सिमेट्रिक कसा झाला, कायरल कार्बन आहेतच. सी, दिस कार्बन इज हॅव्हिंग 4 डिफरंट ग्रुप्स, सो इट इज कायरल कार्बन. This carbon is also having 4 different groups, this is chiral carbon. पण कायरल कार्बन जरी याच्यामध्ये असले तरी सुद्धा हा मॉलिक्यूल सिमेट्रिक आहे. असं प्लेन टाकलं तर सिमेट्रिक होतोय का? नाही होत. इकडे एच येत आहे, इकडे ओएच येत आहेत. ओके, बट इफ वी पास सच अ प्लेन then the molecule became symmetric. See, we are getting the mirror image halves by passing a plane through this bond. या बॉन्ड मधून जर आपण असं प्लेन पास केलं मध्यभागून मॉलिक्यूलच्या तर आपल्याला मिरर इमेज हाल्व्स मिळत आहेत. अँड दॅट्स वाय द मॉलिक्यूल इज ऑप्टिकली इनॅक्टिव्ह. डी आणि एल कसे होते? ऑप्टिकली ऍक्टिव्ह होते, कारण आपण याच्यात बघितलं की सिमेट्री नाहीच आहे. बोथ ऑफ these molecules are asymmetric and that's why one is dextrorotatory, another is levorotatory. But meso-tartaric acid is symmetric. We can pass such kind of plane through the center of this molecule and the molecule is found symmetric. Therefore, it is optically inactive. It is optically inactive. Both of these are optically active, but mesoisomer is optically inactive. So this is about the mesoisomers. So what we discussed today? We started with the exchange method of assigning configuration, and then we seen some examples. Some examples are given for practice to you. After that, we seen the definition of diastereomers, and at last we seen the mesoisomers. So with this we shall finish this lecture. See you in the next lecture. Thank you.